All right, so arc length, remember I talked about arc length being if we took a string around the outside of a circle and then we laid that string out straight and we measured that string, how much would that string be in terms of centimeters, meters, any unit like that. So it's basically the physical distance along the circumference between the 2 points of the arc. We know that a full arc length of a circle would be the circumference of a circle. The circumference of a circle formula is 2 pi r. That would be a full circle. But now we may only be doing a portion of our circle's circumference. And so what we would need to do to find a portion of our circle's circumference is take the amount of degrees that our arc is divided by a full circle of 360, and then we would just multiply that by the circumference of the circumference formula, because that would mean that we are taking a fraction of the circumference of our circle. So arc length, we use the variable s for arc length. And in degrees, we would just take our arc length angle, which I'm going to use this symbol here. This just means that we're talking about an angle, divided by a full circle. This would give me the fraction of the circle that I am trying to find the arc length of. And then I would multiply that fraction by the entire circumference. So this is the arc length formula if my angle was given to us in degrees. Well, what happens if our angle is given to us in radians? We do not need to convert our angle into degrees and then use the arc length formula to find the arc length. There is an arc length formula specifically just for radians. And let's derive that right now. We know that a full circle's 2 pi radians. So if I substitute 2 pi in for that 360 degrees, and then just keep the rest of my formula the same, except I'm going to write the 2 pi r over 1, then I would wind up with the 2 pi's canceling each other out, and I would wind up with my angle in terms of radians times my radius, and then I don't need to write over 1 because it just would divide out to be this. So actually, the arc length formula when we have radians is actually a lot easier to work with than when we have it in degrees. So let's get started. What is the length of an arc if the circle has a radius of 4 and the central angle is 120? So we're going to use the degrees formula, so the first one. So S would be equal to 120 times 360 times 2 times pi times your radius, which is 4. So I'm actually going to write it in exact format and then also write it rounded. It doesn't ask you for what we want, so I'm just going to prepare you for both just in case you see exact or rounded in your homework. So if I multiply, I'm just going to leave the pi alone. I'm going to tack that on at the end. I'm going to multiply the 2, the 4, and the 120. That gives me a 960. Then I'm just going to tack the pi on, and then all over a 360. And now we're going to reduce. Both the numerator and denominator are divisible by 120. A 960 divided by a 920 is an 8. And a 360 divided by a 120 is a 3. So it would be 8 pi over 3 centimeters. That's if I asked you to write it in exact format. If I asked you to round, let's say round to the nearest tenth, you would just type in 8 pi using the pi symbol in your calculator, divided by 3, and you would get about 8.4 centimeters. All right, number 6. What is the length of an arc if a circle has a radius of 10 centimeters and the central angle is 4 pi over 5? When we have pi in our angle, that means our angle was given to us in radians. So we're actually going to use the radians formula, which is just arc length is equal to your radians times your radius. So I'm going to write this in exact format as well, and then also round, because it doesn't ask us. So I'm going to multiply the 10 times the 4 to get a 40 pi over 5. Well, 40 divided by 5 actually comes out to work out nicely. It's an 8 pi centimeters. This is exact format. If they asked you to round, let's just round to the nearest tenth. You're just going to type in 8 pi using the pi symbol in your calculator, 25.1 centimeters. And that's it. All right. What is the exact arc length? So this time we are doing exact. So we're not going to round. Given that the central angle is 30 degrees and the radius is 3. So we're going to use that first arc length formula. You take the amount of degrees divided by 360 times 2 pi times my radius of 3. Multiplying the 30 with the 2 and the 3, I get a 180 pi over 360, which both the numerator and denominator are divisible by 180. And so this reduces to pi over 2 centimeters. That is my arc length that asked for exact, so we just leave it just like that. So for my next one, what is the exact arc length given the central angle of pi over 4 radians and the radius of 12? So we're going to use the arc length formula with radians, which basically just says we're going to take our radians and multiply by our radius. So multiplying that together, I get a 12 pi over 4. 12 divided by 4 is a 3, so I have a 3 pi centimeters. We're going to leave it like that because they asked for exact format. All right, this time we're going to find the measure of our arc in radians given given that our arc length is 4 pi and our radius is 10. So the arc length formula for radians is S is equal to your radians times your radius. I have my radius. So I'm going to put that in for R. I have my arc length. I'm going to put that in for S. So I have a 4 pi is equal to my radians times my radius. To find my radians, I'm going to just divide by 10 on both sides. And then I'm going to simplify. Both 4 and 10 are divisible by 2. So I get my angle in radians to be 2 pi over 5 radians. And that is my answer. All right, that brings us to the end of this lesson.